A 30-kilogram crate is at rest on a 15-degree incline. A strong wind suddenly starts, producing a constant 200 newtons horizontal force on the crate. There is no friction. What is the crate's velocity after it moves 5 meters up the ramp? Was any thermal energy produced? So here's a diagram what's happening in this. So as you can see, there's a crate up and an incline, and there's a 200 forces of newtons going up it, and it travels 5 meters up, and so it ends up around here, and the incline is 15 degrees. So I also drew a force diagram what's happening. So here's the normal force being applied, and then the gravity, and then here's the F cosine theta. As you can see, is going with it. It's like this is going as this is the force applied to the crate, which pushes it up, and then mg sine theta pushes it down. So that's a negative force, and this will be a positive force. And then so this is first state out the given info as well. So as we can see, the mass will be 30 kilograms, and then gravity will be 9.8 meters per second. And then we also know the angle, which will be 15 degrees, that will be the incline. The force was 200 newtons, and the distance was 5 meters. So we also have to, so let's also remember the work energy theorem, which is the total work done by all forces equals the change in kinetic energy. So we're going to be using this equation in order to solve what we're doing. So we're using this theorem to solve what we're doing. So the forces along the direction of motion are the F cosine theta and mg sine theta. And then as I said before, the Fg cosine theta does positive work, while the mg sine theta does negative work. So this is negative and this will be positive. So then the equation will just be F cosine theta times the distance minus mg sine theta times the distance, which will get us, after we plug in the values from the given information, we'll get 200 newtons times cosine 50 times 5 meters minus 30 kilograms times 9.8 meters per second squared times sine 15 degrees times 5 meters. And that will go to 965.925 minus 380.463. And then that's going to be the left-hand side of what we're using. So that's the total work done by the forces. And then the change in kinetic energy just equals 1/2 mv squared. And remember, we're just solving for v, right? So then this is simple. After plugging in the values, we get 30 kilograms over 2, which would just get us 15v squared. And then again, we're just solving for v. So then after we plug in everything, we just set them equal to each other. Total work equals change in kinetic energy. So it'll be 965.925 minus 380.463 equals 15v squared. And then we just put everything in terms of v. So then it will be v equals 584.762 over 15. And that'll get us 6.248 meters per second will be the velocity. That'll be the velocity after it makes it 5 meters. After it moves 5 meters, that'll be the velocity. And then if thermal energy is not produced, which is the second part of the question, thermal energy will not be produced because there's no friction. If friction was included, then we would actually that would be have to taken in fact and would be included in when we found velocity, which we did not. So friction was not included, therefore there's no thermal energy.